This video will walk you step by step with completing the assignment for BLAST for finding homologs that's posted on Canvas. The first type of BLAST that you see on the home page, nucleotide BLAST, is using a nucleotide query. That is the sequence that you enter into the search field to search a nucleotide database. You're literally comparing nucleotides and nucleotides, apples and apples. You're comparing the same thing. It's very straightforward. With protein BLAST, you're entering a protein query to search a protein database. The remaining three types of BLAST are a little bit more complicated to explain. One thing that you can notice is the X at the end and the T at the beginning. So when we use BLAST-X, we're searching a protein database, but we're using a translated nucleotide query. So we're going to put a nucleotide in the search field, and we're going to find the proteins that match it. With T-BLAST-N, we're going to search the translated nucleotide database using a protein query. So we're going to enter a protein sequence, but the search results will be nucleotides. The last example is searching a translated nucleotide database using a translated nucleotide query. This one may be the hardest to understand, but it's really useful if you're looking at any example of convergent evolution, where you expect the nucleotide sequences to be very different from each other, but the protein sequences to match. The second question in the homework asks you to use BLAST-P to find something that's most similar to T-Rex collagen. We can look up this accession number on NCBI, but BLAST also works with accession numbers. Enter the accession number, gene ID, or FASTA sequence is what it says in the query sequence field. So when we paste the accession number and we search all proteins, right, non-redundant protein sequences, we should be able to find what organisms we're looking for. So I hit BLAST, and we see that there are many different sequences that have a poor, or a score of 50 to 80 alignment with this partial T-Rex collagen. So scrolling down, we can look at some of the matches. We have another type of dinosaur, the Brachylophosaurus, but we also have the Synops pyrogaster. If we copy and paste the species name, you'll see that this species that is a good hit is the Japanese fire-belly newt. This is one of the three organisms that we're going to be asked to order. If we scroll down, we can look for either the alligator, right, and we see two species of alligator here, or the rat. If you want to search for something in the page, you can use Control F, and you'll see the Norwegian rat collagen alpha 1 sequence matches, but is a poor match and is much farther down than the other two. The next question asks you to look at what sequences match chicken albumin. We can tell based on the unique identifier that this is a protein sequence. NP means that it's a reference protein. So when we go back to the BLAST homepage, and look for that chicken albumin, look for what the best matches are. One of the first things you should notice is that the chicken albumin protein has many more very close matches with a score greater than 200 in the database. That's not surprising since this is a living species and it's a whole protein sequence. There are no unknown amino acids in this sequence. So look for what species have very similar serum albumins. We see the wild turkey. You can see that obviously like chicken matches with itself very well. And you can look up any of these species. But no example of a non-avian dinosaur appears in these top search results. The next question asks you, again, to think about how the types of BLAST can be used These are the different search tools that are described on the home page. And then the last question asks you to look at an mRNA that produces a non-functional protein and see if there are any examples of how the mRNA is related to mRNAs that produce functional protein. We'll see that there are many good matches. And scrolling down, we'll see that this ice fish that produces an mRNA that does not code for a protein matches with other fish hemoglobin mRNAs that do produce a functional protein. That's it for BLAST for finding homologs. Good luck with the assignment.